Hey everybody, Zach here. Welcome to the 27th lesson of the RTS tutorial series. In this lesson, we'll be setting up our vehicle AI for move to location. This will be done in two parts, and both parts will be released tonight. Now, why am I doing it in two parts? It's simply due to the length, and because throughout this series I have always liked to have the episode end with something that we can actually see. So something that's tangible. For example, if you look over the last several weeks, when I've split the videos up, we've at least had something we can see. When we draw the marquee selection, we can draw it. The next time, we had it have function. Same when we set up the HUDs. I also want to point out that some of the cleanup stuff I said that might be happening later on is actually going to happen in Friday's episode, simply due to the fact that to get some of the stuff to work, I had to do the cleanup earlier. So there might be a change to the schedule for the rest of this section. And finally, I just want to point out, we actually have been working with AI with the character movement already. We haven't done anything like behavior trees. We've done very simple AI. Unfortunately, there is not a vehicle AI in this system. So what we are going to do is we're going to recreate the move to location throughout this episode and the second part of it. That said, fire up your editors and let's get started. To paraphrase one of my favorite movies, well, it looks like we're back in the editor again. And if you don't get the movie I'm referencing, think about the fact that there's a car and a tree. That's all I'm going to give you. And I'll look in the comments to see if anyone works out what movie I'm referencing. Alright, so what we're going to do is we are going to begin to work on the maths that will allow this car to get from here to, say, all the way over there. So the first thing we're going to do is we are going to go to our unit ground vehicle master. And I don't know why there's question marks there when I committed it, but okay. Alright, we're going to close out the deselected and selected decal functions. And in the event graph, what we're going to do is we're going to create a event begin play. And we're going to make a reference cast at this point to our controller. So we're going to get our player controller. Do not get controller like I've done in a few of the episodes. So it's always player controller when you want to get a reference to your player controller. And this will be RTS player controller. Oddly enough. Yes, I am kind of mocking myself for that mistake a few videos back. And then, of course, we're going to pull off of this and make this a reference to our player controller. Actually, I'm just going to call this controller ref. And I will set this in the category of references. Maybe I should call it player controller references, or reference, or ref, so I know what it is. Alright, and then I'm going to do a custom event. And this custom event will be receive, execute. Actually, it's a bad name for that. I'm not going to know what that means. It's going to be receive, move, command. And it's going to need one input, which will be target, and target will be a type vector. So we're going to pass in information on where this needs to go when we trigger this receive move command. Now off of here, we're going to have a function. So I'm just going to go ahead and add a function here, and that function will be called move to location. A move to location is going to have a few bits and bobs, and they're really rather simple. So this one we can go through pretty quickly. We'll have an input, and that input will be our target location, and we will, just promote this to a variable. This variable will be our target. Fairly simple. So we set our target location. We then want to calculate the distance between the car or the vehicle and the target location. So we're going to take our target and we are going to get it. And then we're going to click right above it and we're going to do get actor location. And the actor it's getting the location of is the particular instance of the car. That's why we had that self there. And we'll do vector minus vector. And then we will normalize this. Now, in blueprints, that's called length instead of normalize, if you're used to C++. And so we'll get vector length. What this does is it takes the difference of these two vectors and gets us a float value that represents that difference. It gets us the length of that vector. Or another way to think about that is, if we create a new variable, is that it gets us our initial distance between point A, the car, or the vehicle, and point B, where we want it to go. That's all that's doing. All right, now that we've got, what the distance from the actor, from the vehicle to the target is, well, we then can pass that information along. But to do so, we also need some other things. And I'm going to give you a hint for something that you might want to improve upon in this code right now. Well, we're going to get a new variable, and that variable is going to be used to help calculate the speed. So we know where the item is. We need certain variables to get us to that item. And now one of those variables is our speed. Part of that calculation, we're going to have a new variable, which we'll call starting time. So the time in which we give the command to move to that area, the time that this function initially fires. And this will be of a float, and we're going to set that at this point. Now, what you might want to improve is what I use to set it, and I'm going to use get game time in seconds. This doesn't return our game time. This returns a float for how many seconds the game has been running up until this point. This does not reset at 60. It continues on. So that's a challenge if you want to use our game time to help calculate how fast the car should be moving. I would recommend doing so. We will be, or at least trying to do so, in a later section. This is something we will have to clean up for fidelity of graphics to, or fidelity of our game clock to what we're seeing on the screen. All right. So yeah, that's something for you to clean up. So now we have our target. We have our distance from our target. We have one of the constants, one of the variables we're going to use, which will actually work as a constant because we only set this once, to help us calculate how fast our vehicle should be moving. We are going to reset something. Now, I realize we haven't set this already, so it's going to be a bit confusing. I apologize that I can't explain why. I can't explain what we're doing with it, actually. I apologize that we're doing it slightly out of order. It's just easier to do it now. So we're going to grab this vehicle movement from up here. We're going to drag it onto the graph, and off of it, we are going to set handbrake. We want to make sure the handbrake isn't set at this point. So not only are we resetting it to make sure it isn't set, we're just confirming, hey, no, this isn't set. You're able to go to a location. You're not parked. And next, we are going to set up the call and the timer for our other function. So what we'll do is we'll do set timer by function name. So we're going to set a timer by a function name. And we don't have another function yet. We only have our set decal, or set selected decal, and set deselected. Well, we're going to name a new function. We're going to have a new function we're going to create, and that will actually be where all the calculations take place. And we're going to call that one update movement. And I'm just going to copy that right now. So whenever you type in here, that function that we're calling has to have exactly the same name. So update movement, I've copied it, so when I go to actually create a function, I'm just going to paste that name in to avoid any mistakes. We want this to repeat, so we want it to loop. We want it to loop fairly often, so we're going to have it loop every 0.01 seconds. So it's looping almost as fast as our tick is looping. So this is going to go pretty quick. It's going to fire over and over and over again until we reset it. So let's go ahead and start creating that function. As I said, I copied and pasted that name in. And before we go any further, what I'm going to do is I'm just going to return back to the event graph, and I'm going to take my move to location, and I'm just going to set it here.
I'm going to plug that in, and I'm going to plug my target in. That way, at least that's all set up, and we are ready to go on to the next bit of this. So the update movement, and this part is the confusing part. So in the first half, all we are doing is we're going to set up and update our steering input. So with that in mind, let's put our goal on the map. And actually, let's put our goal on the map. So to do so, we're going to drag this vehicle movement component in. We are going to grab off of it, and we're going to do steering, set steering input. And we're just going to plug this into here. Again, I want to point out this is steering input with a float vector. This is meant for a controller. This isn't meant for, when I say controller, I mean a physical handheld controller, be it a keyboard or mouse, be it a joystick, be it a gamepad. This input here that we're looking to receive information for, especially this value here, the steering value, is based on how far someone's turning a physical wheel. We need to make a calculation that will act as a virtual version of that, which is why this can be really complex and really confusing. And we're going to introduce a new sort of control statement that you've not seen before, but you have conceptually worked with previously. So it's going to look new, it's going to look terrifying, it's going to look scary, but please remember, you've seen it already. You've worked with some similar concepts. You have done similar things just using different nodes. Okay? So don't panic too much. So if our end goal is set steering location, to give you an idea how much space, I really thought I'd turn that off, we need. I'm going to drag that out about to there. Yep, that actually might be too much. Or it might not be enough. We'll find out the fun way. So the first thing we're going to need to do is we are going to need to update our current location. Because if the car is off path, then it doesn't really matter where things are. So we are going to get location, or get actor location. So get actor location. Again, remember this is in a thing that's updating every 0.01 seconds. So this will be fairly this will be updated fairly frequently. We will promote this to a variable, and a local variable, and this will be current location local. And we need to plug that into there. And just so we don't lose track of what's happening in our goal, we are going to plug this back into our set steering. By the way, we will be plugging nothing else between here and there into that main execute line. Everything else is calculations for what goes into this steering. Yeah. Like I said, it's a bit complex. So, we have our location. What we also need to do is we need to locate the target in relation to the vehicle. So we need to know, is the vehicle to the left, to the right of the target? Or is it in front of the target or behind the target? So we are going to put a reroute into here. And we're going to drag off of here. And we're going to get find look at rotation, which returns a value about the sort of where objects are looking at. And the return value is, what's the rotation. So we want the target value as our target. So what direction is our car from a start looking? What's the difference in rotation from our car's location to our target location, to where we're sending the car? That will give us a rotator value. And what we want then is we want to get the rotation of our actor as well. Get actor rotation. There we go. So this gives us what direction our actor is facing. Now if we take these two together, we can get the difference between them. We can get the delta of them. And it can be a normalized delta. So we'll do delta rotator. So all this is rotator A minus rotator B normalized to give me a standard sort of rotator. In other words, not the local information. This is the global information. If you don't understand the difference between local and global in this case, local is So let's look at the tree for a second. The leaves, and we can't actually see the leaves, unfortunately. Oh, yeah, we can. Other instance together. So when we spawn them in here, what happens is the leaves are a subcomponent of the tree, and if we were able to click on the actual location, you would get a number that doesn't match the world space. You would get what's known as a relative location. So that's a location relative to the root of the tree, so the root component. What this is, instead of giving us the relative location, it's giving us the difference in relation to the world itself, to the game world, which is useful. That's what we want. So we're going to break this rotator, and I'll try to show you an example, by the way, of the difference between the local space and the global space towards the end of the video if I can. So we're going to take this rotator, we're going to break it. We don't care about the X and the Y. If we are looking down and we're rotating, so if we're looking down at our car and we rotate it to the left or to the right, we're actually rotating it along the Z axis. So we care about the yaw. And what we want to know is we want to get an orientation of the car. Is the object to our left or to our right? Or is it in front of or behind our vehicle? So we're going to drag off of this, and we're going to do map range unclamped. I'm just going to set that there for a moment. We're going to put another reroute in here, and we're just going to drag down here, and we're going to do in range. We're going to do in range float. All right, so let's just line these up slightly. What these are these are going to be our sort of conditional checks. So this top one will handle our left and right, and this bottom one will handle our true and false for is it in front of the car or behind the car, where in front is true and behind is false. So what it's doing is we're checking, is this yaw value in range of this? If so, then true. So let's do that one. That's the easiest to do, which is 90 to positive 90. So if we're looking down at the car, from the angle the car is facing, the way we've created it, if we look at the angle on the graph, it'll be from negative 90 all the way around to the front to positive 90 covers the front half of the car, whereas negative 90 through to, well, it's positive 90, but that'd be negative, actually that'd be the max, would be 90 on this side through to negative 90 would give you, if you reverse the min and max, would give you the back half of the car. You can also use 180 as well, which we will actually use for our left and right. It's just easier for left and right. So this will return, if the value is in this range, this will return a true. If it is not in this range, it will return a false. We want to include the min, so we want to include the negative 90. We want to include the max and 90. So is it in that range? It will be in front of the car. Now for our left and our right, this is where it gets a bit confusing. I'm just going to put in 180, negative 180 for our A range, positive 180 for our B range. Our out of range A will be minus 1, and our out of range B will be positive 1. So again, if we're looking down at our image, what it is if we're in the range of negative 180, so we are on the left-hand side of the car. If we are in the positive 180 range, we are on the right-hand side of the car. And it will give us, again, a return value that says, are we on that right-hand side or on that left-hand side? So the first thing, and this will get a little bit more clear as we go on, I hope. So the first thing we want to do is we want to set our steering information. Remember, we're going for steering here. We want to set our steering information based on, is the object in front of us or behind us? So this is where we're going to have a sort of new if statement, but it's going to be an if statement with our output rolled right into it. So we're going to right click and we're going to do select float. So if A is true, then pick A from here. So we want to know, is the object, is our target in front of our car? If so, then we want this value to carry forward. All right, let's put a couple of reroutes in because we're going to need them. There we go. So if the object is in front of our car, we want to carry forward this, is it to our left or to our right? We then want to check, if it is behind the vehicle, is it close enough for us to reverse to? So we're going to do another select float. And off of this select float, the A goes in, and we are going to then need to check what our if statement is going to be here. So our pick A if statement will be an and. We need to pass two things through. We need to know that it's not in front of the car. So we want to drag off of here and do not. So if it is not in front of the car, sorry, I did that badly. Drag off of this and do not again. Should be not equal, should be not Boolean. There we go. So if it's not in front of the car, and we're going to drag off of here and we're going to do a less than statement. And what we're going to do is we're going to do a float. And we want to know if it's less than, say, 1,000. We want to know what's less than 1,000 is the distance between and this is centimeters, by the way, the car and the target. So is the target less than 1,000 centimeters from where we want to be? Now, what we're going to do in a little bit later part of this is we are going to create a variable called current distance. Now, we can, right now, if you want, put a dummy variable, an empty current distance. And in fact, that's actually what we'll do. So we will do a promote to a local variable, which will be current distance local. So we have initial distance, and now we have current distance. So is our current distance from our target less than 1,000? And is the object not in front of the car? If both of those are true, then we can reverse to the target. We'll pick A. However, if that is not true, then we want B to carry forward. And what B is going to be is it's going to be the same value, oddly enough, as what is coming out of here. However, just remember, if what's coming out of this A, if, however, the object is behind the car, then we're passing through a 0 into here. So we are just going to plug that into the B there. And we are just going to put in a few reroutes just to make this a bit prettier. And just move this back a tiny bit. There we go. So, is the object in front of us or behind us? Okay. Is the object close enough to reverse if it's behind us? And if we need to reverse, then we need to override the direction of our turns. Because remember, our turns become, so when you're reversing a car and you want to turn to your left, you're going to turn the steering wheel a very different way than you would if you were facing forward and thinking about turning the front end of the car. So we have to calculate that for that inversion as well. Unfortunately, this is a really easy one. We do another select float, and the calculation becomes the difference between +1 and -1. So we're going to plug that into the B, and we'll set A to -1. So what's happening is if we are reversing, then we are going to set our turn to -1. What's going to come out of here, by the way, if you haven't realized, it's going to be in the range of 1 to -1. That's what this is. So all we're doing is we're passing through 1 or -1, 1 or -1. And we keep passing that float through, or something in the range of that float, to control for steering input. So you can turn the wheel fully or you can turn the wheel partially. So when we need to worry about what this pick A is. So this pick A is going to be very simply our value coming off of this return. And we want to know, is it equal, not to a vector, Sorry about that. We want to know, is it equal to a particular float? There we go. There's my float. Took a minute to find it. We're going to plug that directly into there. And the float we want to know, is it equal to or not? Oh, wow. It gave us way too much room. Is it equal to this b here? If it is equal to b, if our return value is, in fact, this 0, 0, then we want to be reversing. Because remember, that's what we're passing through on this in the end when we do our return value, passing through that 0, 0 again. We want to change that 0, 0 to -1. All right. Now, we're only about 25 minutes into the recording. Like I said, the last version I did, this was about 30 minutes in. And we have now set up our steering. So I just want to go over again what's happening here. We are coming in. We are updating our, remember again, when we come in every 0.01 seconds. This is happening a lot within a minute. It's happening a lot within a single second. We come in, we calculate our current speed. We see is what the rotation difference between where our car is facing and where our target is. I said speed, our current location is what we get. We see the difference between what the rotation of the two are. We check, is the object to the left or to the right of the car? Is the target to the left or the right of the car? Is it behind the car, yes or no? If it is not behind the car, then we want to carry forward this, range, it's +1, this out value. If it is behind the car, then we want to push forward to this 0. If it is behind the car, are we close enough to reverse to it? If we are close enough to reverse to it, which is anything under 1,000 meters, or 1,000 centimeters, sorry, then we want to pass forward this A value, which will be our, oddly enough, which will be the A value. Sorry, we want to pass forward. I'm mistaken about that. We want to pass forward this B value, which will be this 0. This B value becomes the A value in the select node. If we are passing that forward, then we need to check, are we actually, do we need to actually reverse? So yes, you could reverse these two nodes. It just makes more sense to me to have them in this way. So we need to reverse. We're passing forward to this 0, 0 from this B. If we've passed forward to this 0, 0, then set the steering to be inverse. So set it to -1. If, however, the object is in front of us, then carry forward with a +1. If it is in front of us, then we're not really going to be worried about, where it's really located. So we're going to go forward. We're not going to have that as true, so we're automatically just going to pass forward that +1 into that return steering value, or that item that ranges up to +1. All right, the next half of the code I will do in a separate video, unfortunately, because it will take about the same amount of time to get through, if not longer. So just to go over what we've done, we've set up this part, as I've mentioned. We've also set up the move to location function, which will trigger when we receive the input to fire this off. And actually, we'll do one more thing before I sign off on this video. And don't worry, I will release the other video for this the same night as this video, just so it's in 2 parts, so it's easier to digest. What we'll do for this last part of this video is we will go to our player controller, and we will just duplicate over this unit movement command stuff, actually. So let's highlight everything in here, minus that last little bit there and that first node there, and we'll do Control-C for copy. Let's go to our event graph, and what we're doing, we're just going to show you what we're doing, is we're going to create a new macro that will be the equivalent to the one we just copied, which is this one. And we're going to put it on the then1 pin. So go to your macros. We're going to do vehicle movement. Okay, so the first thing I'm going to do now that I've done that is move this over here. When did it auto compile? Okay, whatever. I'm going to paste that into there. And I was going to move this over here. Now, if you have any issues where you can't find the receive move command, save what you're doing, compile everything, save what you're doing, close the editor out, and come back in. I've had that issue myself, actually, while working on this. We're going to get rid of this selected units. We're going to get rid of this selected units. And in fact, actually, we're going to get rid of all of this. And we're going to get rid of the stop movement here. We'll plug this back into there. And, sorry, not move it, plug it in. And we'll tighten this up just a bit, just so it's nicer and neater looking. Alright, so let's get our selected ground units into there. And selected ground units into... Sorry, the reroute is why that didn't want to go in there. There we go. Now it'll go in. Even though I'm going to want that reroute in a second. So off this array element, like I said, I'm going to want it in a second. We are going to search for receive move command. If you do not see this, if it is not showing up, like I said, save everything, close and compile. Close your editor and reopen it. I will say in an earlier version of this recording, i.e. the one I'm actually editing this into, it took me 30 minutes to work that out, which is a little bit sad. So we are going to receive that command at this point. What we are going to pass through is that argument on what our location is. So we are going to get our unit movement target location and drag it and drop it into there. So I am just slightly worried this won't fully work, but we'll find out in the end of the next video. If this doesn't work, what we have to do is move the location of that condition and that condition. But that's about it. We have one more thing we'll need to do, actually. So let's just compile that and save it. And this is probably going to cause the same issue as I had with this receive movement. So we're going to create a custom command in the event graph of our player controller. So that custom command will take care of the remove icons. If you notice, we don't have that remove icon here. And it's also part of the reason we made that cast earlier in our ground vehicle. So if we go to our event graph, and let's just go down to near where our units will go, our vehicle movement will go actually, so let's plug that in right now. So that's just ready for us to go a little bit later. We're going to do a right click, custom event, and this will be remove location icons. Actually, I don't know why I said icons, it should be decals. Move location decals. And, you know, to save some time, we're going to go in here, we're just going to copy this, go back to our event graph, paste it in. Is it valid? If so, remove it. Alright, that's all that we need for that bit. And now, in the next video, which again will be released tonight, we will go over the rest of the math to get this to work. Oh, sorry, not this part. To get this to work. We've set the steering up. Now we need to set up the actual throttle, the amount someone is pressing down on the gas pedal. That said, if you have any comments, if you want to see anything in this series, go ahead and drop a comment down below. If there's anything that I haven't covered you want me to cover, just let me know there. Likes, as always, are appreciated. It lets me know I'm bringing you content you value. And, well, I know I'm going to see you a little bit later tonight, but I hope that you have a wonderful day.